In the earliest days of human history, long before books, long before written language, and long before numbers had names, people still lived and worked in a world that required understanding. They needed to know how much they had lost, and how much remained. And even without words for numbers, there was still a quiet and steady need to count. At first, this counting was not spoken, and it was not written. It was simply remembered, carried in the mind through observation and familiarity. A shepherd watching over his animals would notice if one was missing, not because he counted them as we do today, but because something felt different. Something was no longer there. Over time, people began to create simple ways to make this understanding more certain, using small stones and placing one stone for each animal, forming a physical reflection of what they saw before them. If the stones matched the animals, all was well. And if something was missing, the stones would quietly reveal it without confusion or doubt. In other places, people made marks, scratching lines into bone or carving them into wood, with each mark representing one day passed, one item stored, one task completed. These simple markings became some of the earliest forms of recorded thought, a way to hold on to information beyond memory alone. There was no rush in this process, and no need for complexity, only a quiet and steady effort to keep track of life as it unfolded day by day. As generations passed, these marks began to take on patterns, and groups of lines became easier to read than many scattered marks, allowing people to recognize quantity more quickly and with less effort. Instead of counting each line one by one, they began to see small groups, and within those groups, the earliest sense of numbers began to take shape. It was not yet mathematics as we would recognize it, with no equations, no symbols, and no formal systems. But something important had begun. There was awareness, an understanding that quantity could be tracked, that something could be measured, and that the world could be understood through patterns. This awareness grew slowly, very slowly, across years and then centuries, as people refined these simple ideas and began to share them with others. They passed them down, teaching others how to count, how to remember, and how to keep track of what mattered in daily life. And so, quietly and without recognition, the foundation of mathematics was being laid, not in great cities or grand halls, but in fields, in homes, and in the quiet rhythms of ordinary life. A stone for each animal, a mark for each day, and a pattern for each group. Simple things, but deeply meaningful ones. Because from these small beginnings would come everything that followed: numbers, measurement, understanding, and eventually the language of mathematics itself. And so we begin here, in the quiet and patient beginnings of counting, where the simplest ideas would slowly grow into something far greater. For now, we rest in that simplicity, moving gently from one to another, letting the rhythm of counting settle in, calm and steady. As human life became more settled, and communities began to form along rivers and fertile lands, the need for counting slowly grew into something more precise, something that required not just knowing how many, but understanding how much. In ancient Egypt, where the great river Nile shaped daily life, people depended on the land for survival, and the land itself was constantly changing. Each year, the Nile would rise and overflow its banks, spreading rich soil across the fields. And while this brought life and growth, it also erased boundaries, washing away the markers that once divided one piece of land from another. Because of this, the people needed a way to restore what had been lost, to measure the land again, to redraw the lines, and to determine who owned what. And so, measurement began to take form. Using ropes, often knotted at regular intervals, workers would stretch these lines across the ground, carefully measuring distance and space, creating order out of what had been washed away. This was not mathematics as we know it today, but it was something very close, a practical and steady use of numbers to bring structure back to the world. Alongside measuring land, the people of Egypt also needed to build, and their buildings required accuracy, balance, and careful planning. The Great Pyramids, rising slowly over many years, were not the result of guesswork, but of careful measurement and repeated patterns, where each stone had its place and each angle had its purpose. In time, systems began to form. Numbers were written using symbols, simple and clear, each one representing a value, allowing people to record amounts, track goods, and manage resources, instead of relying only on memory or physical objects like stones. They could now write things down, preserving information for later use. This made trade easier. It made planning possible. And it allowed knowledge to be shared beyond a single moment in time. Their number system was based on tens, much like the one we use today, though it looked very different, with separate symbols for ones, tens, hundreds, and beyond. To write a number, they would combine these symbols, repeating them as needed, building larger values out of smaller parts. It was simple, but it worked. And because it worked, it endured. Measurement extended beyond land and building. It reached into daily life, into the storage of grain, the timing of seasons, and the organization of labor. People needed to know how much food was stored, how much was needed, and how long it would last. They needed to understand time, watching the movement of the sun and the regular patterns of the Nile, learning to anticipate what would come next. In all of this, mathematics was not something separate from life. It was part of life, quietly present in decisions, in work, and in survival. There was no rush toward complexity, no desire to create abstract systems for their own sake. Instead, there was a steady movement forward, guided by need, shaped by experience, and refined over time. And so, in ancient Egypt, mathematics began to move beyond simple counting and into something more structured, something that could measure the world. not just observe it. The land could be divided. The harvest could be planned. The future could be anticipated. And all of this came from a simple idea that quantity and space could be understood, recorded, and used. This was the beginning of measurement. Not perfect, not complete, but steady and reliable, growing quietly with each passing generation. And as these ideas spread and developed, they would travel beyond Egypt, influencing other cultures and shaping the way people understood numbers and space. But for now, we remain here, along the banks of the Nile, where the rhythm of water and land gave rise to a new kind of thinking, one that would continue to grow in the centuries to come. In the next part, we will move eastward to another ancient civilization, where numbers would take on new forms and where mathematics would begin to deepen in unexpected ways. For now, we rest in the steady rhythm of measurement, where land, time, and life were gently brought into order, one careful step at a time. As civilizations continued to grow and spread across the ancient world, new ways of thinking began to emerge, shaped by different lands, different needs, and different patterns of life. To the east of Egypt, in the region known as Mesopotamia, between the great rivers Tigris and Euphrates, another early civilization began to develop its own approach to numbers and measurement. Among these people were the Babylonians, who would quietly shape the future of mathematics in ways that are still felt today. Like those before them, the Babylonians needed to count, to measure, and to keep records. But over time, their system became more detailed, more flexible, and more refined. Instead of carving simple marks or repeating symbols over and over, they developed a system based on place and position, allowing the same symbol to carry different meanings depending on where it was placed. This idea, though simple, was powerful. It meant that numbers could grow larger without becoming more complicated to write, and it allowed for greater precision in calculation and record keeping. Their system was built around the number 60. Not 10, as we use today, but 60, a number that can be divided in many ways, making it useful for measurement and for working with fractions. Even now, we still see traces of this system. There are 60 seconds in a minute, 60 minutes in an hour, and the circle is divided into 360 degrees. These patterns, so familiar today, quietly reach back to the work of the Babylonians. To record their numbers, they used marks pressed into soft clay, forming wedge-shaped impressions known as cuneiform. With a simple stylus, they would press shapes into the surface, creating a written system that could be preserved once the clay hardened. These clay tablets became records of trade, agriculture, astronomy, and daily life, holding numbers and calculations that could be studied and understood long after they were made. As their system developed, the Babylonians began to move beyond simple counting and measurement and into the early stages of calculation. They created tables, lists of numbers that helped them solve problems more quickly, allowing them to multiply, divide, and work with proportions. This was not done for theory or curiosity. It was done because it was useful, because it helped them manage resources, track goods, and understand the patterns they saw in the world around them. They also turned their attention to the sky, watching the movement of the sun, the moon, and the stars. They began to notice repeating cycles, patterns that could be predicted and recorded. To do this, they needed numbers that could handle time, movement, and change. And their system allowed them to do this with a quiet kind of precision. There was still no rush toward complexity for its own sake. Everything remained grounded in purpose, in observation, and in the steady rhythm of daily life. And yet, something was changing. Mathematics was beginning to move beyond simple tracking and measuring, and into something more structured, something that could solve problems and reveal patterns more clearly. The idea of position within a number, the use of 60 as a base, and the development of calculation tools all pointed toward a deeper understanding of how numbers could work together. These ideas would not stay in one place. They would travel. They would influence other cultures, shaping the way mathematics continued to grow across the ancient world. And though the Babylonians may not have seen the full impact of what they were building, their quiet innovations would echo forward through time, becoming part of the foundation on which future mathematics would stand. For now, we remain in this ancient land of clay tablets and quiet calculations, where numbers were pressed gently into the earth, and where patterns began to reveal themselves more clearly. In the next part, we will move to the world of ancient Greece, where mathematics would take on a new direction, shifting from practical use toward reasoning, logic, and deeper understanding. For now, we rest in the steady patterns of Babylon, where time, number, and observation came together, forming a system that still lingers quietly in the way we measure our world today. As time moved forward and ideas continued to spread across the ancient world, mathematics began to take on a new shape, one that was less focused on daily tasks and more centered on understanding. In the land of ancient Greece, people began to ask not only how numbers worked, but why they worked, and what deeper patterns might lie beneath the surface. While earlier civilizations had used mathematics for building, measuring, and tracking, the Greeks turned their attention toward thought itself, exploring ideas in a quiet and careful way. They were not in a hurry. They were not trying to solve immediate problems. Instead, they observed, reflected, and reasoned. Among them was Pythagoras, who believed that numbers were not just tools, but something more fundamental, something that could describe the structure of the world itself. To him, and those who followed his thinking, numbers carried meaning beyond counting, revealing relationships that could be understood through patterns and proportion. They studied shapes. They studied lines. They studied how things fit together. A triangle was no longer just a shape drawn in the sand. It became something to be understood, something with properties that remained true no matter where or how it was drawn. From this way of thinking came simple but lasting truths, ideas that did not change with time or place, but remained steady and reliable. These truths could be shown step by step through reasoning, rather than through observation alone. Another figure, Euclid, gathered many of these ideas and organized them into a clear and structured form, writing them down in a way that others could follow. His work did not rush. It moved slowly, carefully, building one idea upon another, each step resting on the one before it. This way of thinking introduced something new. Proof. Instead of simply saying that something worked, the Greeks wanted to show why it must be true, using logic and clear steps that anyone could follow with patience. This was a quiet shift, but a powerful one. Mathematics was no longer only about what could be seen or measured. It became something that could be understood through thought alone. Lines that had no thickness, points that had no size. Ideas that could not be touched, but could still be known. There was a calm discipline to this way of thinking, a steady movement from one idea to the next, without leaps or guesses, only careful reasoning. And yet, even with this deeper focus, the tone remained gentle. There was no urgency, no need to rush toward conclusions. Only a quiet trust that truth would reveal itself, one step at a time. These ideas spread slowly, carried by teachers and students, passed from one generation to the next, shaping the way people understood not only mathematics, but thinking itself. Mathematics became a language of certainty, a way to move from question to answer with clarity and confidence, guided by logic rather than assumption. And though this work may have seemed distant from everyday life, its influence would reach far beyond the quiet spaces where it was first explored. Because once people learned how to reason in this way, they could apply it to many things, building knowledge carefully and deliberately. For now, we remain in this world of thought and reflection, where mathematics became something more than counting or measuring, becoming instead a way of understanding the structure of reality itself. In the next part, we will move into the world of ancient Rome, where mathematics would return to a more practical role, shaped by engineering, construction, and daily life. For now, we rest in the quiet clarity of Greek thought, where ideas were explored gently, and where truth was uncovered step by step, with patience and care. As the influence of Greek thought spread and slowly blended with other cultures, a new civilization rose to prominence, one that valued structure, order, and usefulness in all things. In the world of ancient Rome, mathematics did not become a subject of deep philosophical reflection, but rather a tool, something to be used, applied, and relied upon in daily life. The Romans were builders. They constructed roads that stretched across great distances, aqueducts that carried water into their cities, and structures that stood with strength and balance. To do this, they needed measurement. They needed consistency. They needed systems that worked. And so, mathematics in Rome remained practical, steady, and focused on results. Their number system, known today as Roman numerals, used letters to represent values, forming numbers through combinations of symbols. These symbols, simple and recognizable, allowed them to count, record, and organize information, even if the system itself was not designed for complex calculation. It was enough. Enough for trade, enough for construction, enough for governance. Roman engineers relied on measurement to ensure that their roads remained level and their structures remained stable. They used tools to measure distance and angle, applying knowledge in a consistent and repeatable way. There was no need to explore abstract ideas or to prove deep theories. What mattered was whether something worked, whether it held, whether it lasted. Time, too, was organized carefully. Days were divided, schedules were maintained, and systems were put in place to manage the flow of life within a growing and complex society. Mathematics supported all of this quietly. It was not the focus, it was the foundation. In markets and trade, numbers helped determine value, track goods, and manage exchanges between people. Merchants needed to know quantities, prices, and totals. And though their system required effort, it served its purpose well enough. There was a rhythm to Roman life, and mathematics moved with that rhythm, steady and reliable, never drawing attention to itself. While the Greeks had asked why, the Romans asked how. How can this be built? How can this be measured? How can this be organized? And in answering those questions, they created systems that would influence the world for generations to come. Even without advancing mathematics in the abstract sense, they preserved and applied what had already been discovered, carrying it forward through their vast network of roads, cities, and communities. Their work ensured that knowledge was not lost, but continued, quietly moving from place to place, waiting to be developed further in the centuries ahead. And so in Rome, mathematics remained grounded, connected to the physical world, tied to the needs of people and the structures they built. It was not about discovery. It was about application. And in that application, there was a quiet strength, a steady reliance on what was known, used day after day, without question. As time moved on and the Roman world began to change, much of this knowledge would pass into new hands, carried into the next era of history. In the next part, we will enter the period often called the Middle Ages, where mathematics would be preserved, translated, and slowly transformed in ways that would shape its future, once again. For now, we rest in the steady and practical world of Rome, where numbers served their purpose quietly, supporting the work of a civilization built on order, strength, and endurance. As the Roman world slowly faded and new cultures began to rise, much of what had been built, written, and understood entered a quieter season. In the period known as the Middle Ages, knowledge did not disappear, but it was no longer advancing in the same visible and steady way. Instead, it was being preserved across different regions, in monasteries, schools, and centers of learning. Individuals carefully copied texts by hand, preserving the ideas that had been passed down from earlier civilizations. These copies were slow to produce, requiring patience and attention, but they ensured that knowledge would not be lost. Among these preserved works were the mathematical writings of the Greeks and others, carried forward not through widespread use, but through careful stewardship. In parts of the world influenced by the Islamic Golden Age, scholars began to study, translate, and expand upon these earlier ideas, bringing together knowledge from Greece, Egypt, and Babylon. They translated texts into Arabic, making them accessible to new generations. And in doing so, they did more than preserve. They refined. Mathematics began to grow again, quietly and steadily. Scholars explored numbers in new ways, developing clearer methods for calculation and introducing ideas that would later become central to mathematics as we know it today. One of the most important developments during this time was the spread of a number system that included the concept of zero, along with a more flexible way of writing numbers. This system, which had roots in earlier cultures, allowed calculations to become simpler, more efficient, and easier to understand. Over time, these ideas began to move into Europe, carried through trade, travel, and the sharing of knowledge across cultures. At first, change was slow. Old systems remained in place. New ideas were not immediately accepted. But gradually, the advantages became clear. Calculations that once required effort and repetition could now be done more easily, and numbers could be written in a way that made patterns more visible. In this quiet period, mathematics was not loudly advancing, but it was being prepared for what would come next. Knowledge was being gathered, translated, and refined, like seeds waiting beneath the surface. And while much of daily life remained focused on survival, faith, and community, these small and careful efforts ensured that the ideas of the past would not be forgotten. Instead, they were carried forward, preserved through time, waiting for a new season of growth. There was patience in this process. No urgency, no sudden change. Only a steady and faithful continuation of what had already begun. And in that patience, something important was taking place. The foundation was being strengthened. the tools were becoming clearer. The path forward was being quietly prepared. As this period continued, the stage was set for a renewed interest in learning, discovery, and understanding. In the next part, we will enter the time of the Renaissance, where mathematics would begin to grow again more visibly, shaped by curiosity, creativity, and a renewed desire to explore the world. For now, we rest in the stillness of the Middle Ages, where knowledge was carefully held, gently passed on, and quietly protected, ensuring that the light of understanding would continue to shine, even in a slower and quieter time, as knowledge continued to move quietly across cultures and generations. Mathematics began to take on a new form, one that allowed people to think not only about numbers, but about relationships between numbers. This new way of thinking would come to be known as algebra. In the regions influenced by the Islamic Golden Age, scholars were studying the works of earlier civilizations, preserving them, translating them, and slowly building upon them. Among these scholars was Al-Khwarizmi, whose work would help shape this new direction in mathematics. Rather than focusing only on specific numbers, he explored ways to describe problems in a more general form, allowing the same method to be used again and again. Instead of solving one problem at a time, mathematics could now describe a pattern, a relationship, a structure that applied to many situations. This was a quiet shift, but an important one. Numbers were no longer only things to count or measure. They became part of something larger. They became part of a system. To make this possible, unknown values were introduced, quantities that were not yet known, but could be represented and solved for. At first, these unknowns were described in words, carefully written out and explained step by step. Over time, symbols would take their place, making the process simpler and easier to follow. This allowed people to solve problems involving trade, inheritance, land division, and other practical needs in a more consistent and reliable way. There was still no rush, no complexity for its own sake, only a steady effort to bring clarity to problems that needed answers. Equations began to form, though not in the symbolic way we see today, but as structured explanations, guiding the reader through a process. Balance became an important idea. If something was added to one side, it must be added to the other. If something was removed, it must be removed equally. This sense of balance gave mathematics a new kind of stability, a way to move from what was unknown to what could be known. And though these ideas were written carefully and explained slowly, their impact was far-reaching, because once a method could be repeated, once a pattern could be followed, mathematics became more than a collection of ideas. It became a tool for solving problems in a predictable and dependable way. These methods spread gradually, carried through learning and translation, moving into new regions and influencing future generations. At first, they may have seemed unfamiliar, different from the older ways of counting and measuring. But over time, their usefulness became clear. And with that clarity came acceptance. Algebra did not replace what came before. It built upon it, extending it, giving it new depth. And in doing so, it prepared the way for even greater developments, opening the door to new ways of thinking about numbers, patterns, and relationships. For now, we remain in this quiet moment of transition, where mathematics began to move beyond the visible and into the abstract, where ideas could be explored without needing to be seen or touched. In the next part, we will explore the concept of zero, a simple idea that would quietly transform mathematics in profound ways. For now, we rest in the gentle balance of algebra, where unknowns become known, and where problems are solved step by step, with patience and clarity. As mathematics continued to grow and develop across different cultures, new ideas began to emerge, some of them small and quiet, yet carrying a depth that would only be understood over time. One of these ideas was the number zero. At first, the idea of nothing may seem simple, almost too simple to notice. But in mathematics, the concept of nothing required careful thought. In earlier systems, numbers were used to count what was present, objects, days, distances. But there was often no clear way to represent what was not there. And yet, the absence of something can be just as important as its presence. In parts of the ancient world, particularly in India, mathematicians began to explore this idea more deeply, developing a symbol to represent an empty place within a number. At first, this symbol served as a placeholder, helping to show the difference between numbers that might otherwise appear the same. Over time, it became something more. Zero was no longer just a space. It became a number in its own right. This was a quiet but meaningful shift, because once zero was understood as a number, it could be used in calculations, just like any other value. It could be added. It could be subtracted. It could stand within a system, holding its place with clarity. This made number systems more flexible, more precise, and easier to work with. The idea of zero worked naturally within place value systems, where the position of a digit determines its value. Without zero, it would be difficult to distinguish between different magnitudes. With zero, numbers could expand clearly and consistently. As this idea spread, it moved through cultures and across regions, carried through trade, scholarship, and the quiet exchange of knowledge. In time, zero became part of the number system used throughout much of the world, though its acceptance was gradual. Some found the idea unusual, difficult to grasp. How could nothing be something? How could absence be written, counted, or used? And yet, over time, its usefulness became clear. Calculations became easier. Patterns became more visible. Numbers could grow larger without confusion. Zero brought a kind of balance to mathematics, allowing systems to remain organized and complete. It did not draw attention to itself. It did not stand out. And yet, it was essential, like silence in music or space in a room. It gave structure to everything around it. Without it, much would feel unclear. With it, everything found its place. And so, this simple idea, this quiet symbol, became one of the most important elements in mathematics, shaping the way numbers are written, understood, and used. For now, we rest in the stillness of zero, where nothing becomes something, and where absence itself holds meaning. In the next part, we will move into the time of the Renaissance, where mathematics would begin to grow more rapidly, influenced by art, science, and a renewed curiosity about the world. For now, we remain here, in the calm and quiet presence of zero, where even nothing has its place, and where simplicity reveals its quiet strength. As time moved forward, and the Middle Ages slowly gave way to a new era, there came a renewed interest in learning, observation, and discovery. This period would come to be known as the Renaissance. In places like Italy and across parts of Europe, people began to look again at the world around them with fresh curiosity, not only preserving knowledge, but expanding it. Artists, builders, and thinkers sought to understand proportion, balance, and beauty, and in doing so, they found themselves drawn naturally toward mathematics. Patterns began to appear more clearly in architecture, in painting, in the natural world. Lines were studied. Shapes were refined. Proportions were measured with care. Mathematics became a quiet partner in creativity, guiding the way things were built and designed. Perspective, the technique that allows a flat image to appear three-dimensional, relied on careful measurement and an understanding of space. Through this, artists could create depth, drawing the eye into the scene in a calm and natural way. Numbers and geometry were no longer hidden behind the scenes. They became part of the visible result. In this time, people also began to revisit earlier ideas, studying the works of those who had come before, building upon them with new tools and new understanding. One such figure was Leonardo da Vinci, who observed the world with patience and care, seeing connections between mathematics, nature, and design. He studied proportion in the human body, patterns in nature, and the balance found in well-formed structures, recognizing that numbers could describe not only function, but beauty. This period was not rushed. It unfolded gradually as ideas spread through books, conversation, and shared work. Mathematics continued to grow, not in isolation, but alongside art, science, and daily life. woven into the fabric of discovery, people began to see that patterns were everywhere. In the arrangement of leaves, in the shape of shells, in the structure of buildings, and through mathematics, these patterns could be understood, described, and even predicted. There was a quiet excitement in this, though not loud or hurried. A steady realization that the world was ordered in ways that could be explored gently, one observation at a time. New symbols and methods continued to develop, making it easier to express ideas and share them with others. Mathematics became more accessible, more visible, more connected to the world people could see and experience. And yet, even with this growth, the pace remained measured, careful, intentional. Ideas were tested, refined, and passed on, forming a bridge between what had been preserved in earlier times and what would come next. For now, we remain in this season of renewal, where mathematics and creativity move together, revealing patterns that had always been present, waiting to be noticed. In the next part, we will explore the beginnings of calculus, where mathematics would take another step forward, helping to describe motion, change, and the passage of time. For now, we rest in the quiet beauty of patterns, where numbers and shapes come together gently, forming a deeper understanding of the world around us. As the Renaissance continued and curiosity about the world deepened, people began to ask new kinds of questions. Questions not just about what things were, but about how they changed. How does something move? How does it grow? How does it shift from one moment to the next? These were not easy questions to answer, because change is not something you can hold still. It is always happening, always moving, always passing from one state into another. And so mathematics began to move in a new direction, one that sought to understand this quiet and constant motion. In this time, figures such as Isaac Newton and Gottfried Wilhelm Leibniz began to explore ways to describe change using numbers and patterns. They were not working together, and yet, in different places, they arrived at similar ideas, each seeking to understand how things move and how they accumulate over time. This work would come to be known as calculus. At its heart, calculus is not complicated. It is simply a way of looking closely at change. If something is moving, how fast is it moving right now? If something is growing, how quickly is it increasing? If something is being added, how much has been gathered over time? These questions led to two gentle ideas: looking at change in a single moment and looking at change over a stretch of time. The first asks, what is happening right now? The second asks, what has happened overall? To understand this, imagine watching a quiet stream. The water is always moving, never still. Yet at any single moment, you can notice its flow, its direction, its speed. And over time, you can see how much water has passed, how it has shaped the land, how it has slowly changed its surroundings. Calculus gave people a way to describe both of these views, the moment and the whole. This was a new kind of understanding, one that required patience, careful thought, and a willingness to observe things that could not be easily seen. There was no rush, no sudden leaps, only a steady unfolding of ideas, built step by step. And though the symbols and methods would later become more detailed, the heart of calculus remained simple. Change is happening, and it can be understood. This idea allowed people to study motion, to understand the movement of planets, the flow of water, and the growth of things over time. It connected mathematics more closely with the natural world, providing a language for processes that had always been present but not fully described. And yet, even with this deeper understanding, the tone remained quiet. There was no need for urgency, only observation, only patience, only the steady movement from question to understanding. As these ideas spread, they became part of the growing body of mathematics, influencing science, engineering, and the way people understood the world around them. But for now, we rest in the gentle idea of change, where motion is observed, growth is understood, and time moves forward in a calm and steady way. In the next part, we will move into the modern era, where mathematics continues to expand, shaping technology, science, and daily life in ways both seen and unseen. For now, we remain here, in the quiet flow of calculus, where change is not something to chase, but something to observe, one moment at a time. As time continued to move forward, mathematics did not come to an end, nor did it reach a final form. Instead, it continued to grow, quietly expanding into new areas, adapting to new questions, and becoming part of the world in ways both seen and unseen. In the modern era, mathematics is no longer limited to counting, measuring, or even observing change. It has become a language, one that helps describe patterns, systems, and relationships across many areas of life, from science to engineering to technology. Mathematics works quietly in the background, supporting the systems that shape daily life. It helps guide the movement of machines, the flow of information, and the structure of the tools people use every day. And yet, for most people, it remains unseen. Much like in the beginning, when a stone represented one, or a mark represented a day, mathematics still serves as a way of understanding what is happening, even if it is not always noticed. New branches of mathematics have developed over time, exploring ideas that reach far beyond the physical world. Some study patterns that repeat Some explore relationships that shift. Some describe systems too large or too small to see directly. And even as these ideas become more detailed, the foundation remains the same. Numbers, patterns, relationships. The same quiet elements that began long ago continue to support everything that has followed. There is still no need for urgency, no need to rush to understand everything at once. Mathematics does not demand attention. It does not force itself forward. It simply exists, steady and reliable, offering a way to make sense of the world for those who choose to look more closely. In this way, it has remained consistent across time, from the earliest marks carved into bone to the careful measurements along the Nile, to the clay tablets of Babylon, to the quiet reasoning of Greece, to the practical work of Rome, to the preservation of knowledge, to the birth of algebra, to the understanding of zero, to the patterns of the Renaissance, to the gentle study of change. All of it forms a continuous path, a path that has never truly stopped, only slowed, shifted, and continued. And now, in the present, that path remains open, still growing, still unfolding. But for now, there is no need to follow it further. Instead, we pause. We rest in the understanding that mathematics, in all its forms, began with something simple: a need to notice, a need to count, a need to understand. And from that beginning, everything else followed, slowly and steadily, across time. So we return, gently, to where we began. One, and then another, and then another. A quiet rhythm, a steady pattern, a simple beginning